In this lesson, you will learn to use the simulation process to gather evidence and make conclusions based on that evidence. A fair die implies that each side is equally likely to occur. Let's take a look at one side and run a simulation to determine the range of outcomes for 30 rolls. In other words, would it be unusual to get results like ours in this chart if the die were fair? Is there a red flag with the number of times a 5 is rolled? Or that the die seems to favor the number 6 more than any of the other numbers? Let's run a simulation to determine possible results if the die were fair. What type of fair die representation could we create for this simulation? In this situation, we have a die with 6 sides. How could we represent the die? We could make a spinner with a paperclip and pencil, with the paper folded or lines drawn such that we would have 6 sections. Or we could use a 6-sided fair die. We could have a paper bag with 6 items representing 6 different sides of the die. Any of these would be a good simulation model. But in this lesson, I'll use the paper bag model with 6 different markers in the bag. I'm going to look solely at the number 6. However, you could have chosen any side of the die to analyze because we're going to extend our results to all the sides, since a fair die implies that each side is equally likely. The first step is to identify our problem. Is it unusual for a 6 to appear 7 times when rolling a fair die 30 times? Next, we look at our assumptions. We assume the probability of picking any marker or rolling any number on a die is 1 out of 6. Each turn does not affect the outcome of the next turn. Then we describe our process. We will assign each marker in the bag a number, 1 through 6. Put the markers in the bag and then shake it. Pick out one marker, record the results. Then put the marker back into the bag and repeat this 30 times. Then count the number of times a 6 was chosen. Since repetition is a very important part of the simulation process, and it helps to ensure we calculate an accurate probability, we need to repeat this process multiple times. I chose to repeat the process of choosing 30 markers 50 times and recorded how many times the number 6 appeared from each time we chose 30 markers. While repeating this process 50 times, I recorded the number of times the 6 appeared and recorded the results on a frequency table. Go ahead and pause the video and try the simulation on your own. You can make a sketch of my results and then add your results on top of this frequency table as well. Finally, evaluate our results. Based on our graph, it was uncommon to see a 6 appear more than 9 times or less than 2 times. This shows that it is not unusual for a 6 to appear 7 times. Looking at the rest of the numbers in our original situation, none of them have a frequency higher than 9 or less than 2. This leads me to believe that the die could be fair. Now it's your turn. Based on your findings, how could the table have been written such that there would be evidence that the die was unfair? Pause the video to work out the following problem. Click play to continue. Let's look at how we could solve this using what we found. It is very unusual to get a frequency below 2 or above 9. Having a frequency of 0 or 12 would indicate that perhaps the die was unfair. Take out your notes and make sure you write down the purpose and the procedure for simulations. The purpose for creating simulations is to create a model that represents a given situation in order to make predictions of the future behavior of that situation. The procedure for running a simulation can be summarized with the acronym PADRE, P-A-D-R-E. P stands for problem. In your own words, describe the problem. A is for assumption. Define your assumptions. D stands for describe. Describe the process for obtaining your results so that it could be replicated by someone else. R is for repeat. Repeat your process. E is for evaluate. Evaluate your results. In this lesson, you have learned to use the simulation process to gather evidence and make conclusions based on that evidence. Thank you for watching this lesson. See you next time.